Okay, previously you deal with mutually exclusive. So it can be one event or another event. But now we are dealing with two events that must be happening at the same time. So when you see this word, both events must happen at the same time. So whenever there's an AND case, take note, we make use of multiplication. Later we'll see the example. Now we zoom in on this one first. Alright? But it's very difficult. For a start, I will ask you all to draw a tree diagram. Alright? Let me draw the tree diagram and then we simplify the problem. So take note, in this question, the keyword is replace. After you draw the first pen, you must put it back and take note of the color. Then you draw the second pen and take note of the color. Alright? So I'm going to draw a probability tree that identify this particular action that we are doing. Okay, unlike the question yesterday, the probability tree here, every branch has a different fraction of probability. Alright, they are not equal anymore. So what is the chance of drawing a blue pen? It's actually 5 out of 12. Am I right? So I need to write 5 out of 12 on this branch. Likewise, what happened to the red? 7 out of 12. Take note, all these branches must have a number, which is the probability. And one branch must always sum up to number 1. Okay? The idea is each of the branch must always sum up to number 1. Okay? Since the pen is being replaced, the probability for the second pen in terms of the branches remains the same. Okay, I'm going to make use of the probability tree for us to do our respective question. First pen selected is red. Ayo, so easy. The first pen selected is red, is this particular branch. Am I right? No need to look at others, 7 over 12. So let me write that down. The second pen selected is blue. Given the first pen selected is red. So there's a condition. Am I right? The first pen is red. So I go for the first pen is red. Second pen is what color? Blue. So it's the first pen red color and the second pen must be blue color. So if I follow in this direction, remember it's an AND scenario. So the first branch is 7 over 12. The second branch is 5 over 12. What must I do to these two fractions? Multiply. So please press your calculator. Okay, so simplify your answer. Actually, part 3 is a more conventional way, alright, of saying part 2. So you will see part 3 more often than part 2, but they mean the same thing. So the approach is still the same. First pen must be red, second pen must be blue. Follow the 3 branch and multiply them together. So the answer should be the same as part 2. Am I right? Okay, so I won't say too much. Okay, now comes an interesting one. The second pen selected is blue. Did they say about the first pen? No. Okay, so I'm going to do my working a little bit longer. See my working first. Not that you have to write everything, but you take a look at what I'm doing first. Notice, if the second pen is blue, there are 2 different paths. Okay, I'm going to show you the conventional way of writing first. So, the 2 paths tells you that, it could be the probability that you get a blue pen, or the probability that can be a red-blue pen. Agree? Either one of these. One path or the other path. Or the other path. When you see the word or means plus. So different path, you need to add them together. Because it can be this path or the other branch. Okay? But within the same branch, you multiply because it's an AND scenario. So what is blue? 5 over 12 times 5 over 12. Put in the bracket. Likewise, red-blue. Red-blue, you actually got it in the first part. But if you don't want to write the answer, okay, you can still write the working. Then, we sum them together. Okay, now comes the last one. One pen is red and the other one is blue. You try yourself. Okay, check the phrasing. One pen is red, the other one is blue. You all told me there can be 2 different paths. let's consider red-blue. But it can be the case of blue-red as well. Alright? So it can be red-blue, which is here, or blue-red, which is here. So within the branches, you will need to multiply them together. Okay? There you have it. The first kind of tree diagram that deals with different situations happen at the same time. Okay, so take note in this question, you are supposed to draw the tree diagram and take note there's no replacement. So the original denominator will reduce after you draw one ball out. So this is something to keep in mind. Okay, the first branch should look something like this. No issue with the first ball. But take note, don't just write like that. If there are numbers you can simplify, please reduce to lowest term as well. Alright, this is what I urge you to do. And that is for the first ball. So likewise, there are two balls chosen. So I need to branch out again. I'm looking at the top branch. A red ball has been chosen. If a red ball originally has 8, I chose one red ball. How many red balls are there left for the second one? 7. Is it 7 out of 16? No, because I took one ball out of the total number. So must be 16 minus 1, 15. But any changes for the blue and red? No. So I'll just write 7 over 15, 1 over 16. That's for the top one. Sorry, not 16, 15. Apology, 1 over 15. Do likewise for the other two branch. Where the blue ball is taken out, likewise the white ball is taken out. Alright, after I fill in all the respective branches, please double check any particular branch I can reduce to lowest term. There is. Okay, so I make an effort. Oh, this is actually 2 over 5. Alright, the rest I don't think I can reduce to lowest term. And think of your last branch is 0. Teacher, how come can be 0? Because the white ball is already taken out, right? There's no other chance to take a white ball for the second one. And one thing to check, make sure within one branch, the number will always sum up to number 1. That is something that you can check for yourself. Okay? Very good. You told me there are 2 possible branches. They will give me red, blue. So I have a red followed by blue, or if not, blue followed by red. Let me multiply them together and sum them respectively to see what is her mistake. Okay, if you skip the first step, it's fine. But I'm just showing you the 2 respective branch, which is highlighted in green, how it comes about. Multiply the branches. There are 2 different branches, then we add them together. So clearly, there's a mistake that Cheryl made. And what Chef indicated is, what Cheryl did was only include red, blue. If you get the probability for red, blue, it's 7 over 30. But what Cheryl forgot to do is, she forgot to include the second one, which could be blue, red. So in my answer, very simple. Cheryl forgot to include the case of blue followed by red ball. Okay. First part straightforward. First ball is red, second ball is blue. Go for the stem. One red while the other one is blue. Can be the case of blue-red, which is the case of what we did earlier on. So I'm just going to use my answer from here to write over here for part B. Alright, because it's basically the same working. So no need to redo everything. So I only consider probability of red, red. Add to the one of probability for blue, blue. So look for the stem again. Red, red. Followed by blue, blue. Look for the correct stem and insert the number. Okay, class, I also give you a hint. The marks are awarded like that. Okay, I give you a hint. This is a strong hint. Part A is worth 1 mark. Part B is worth 2 marks. Part B, part C is also worth 2 marks. So you know already, there's more than one when it's worth 2 marks. Agree? There's more than one branch.